So we've spent time working on quadratic equations for quite a while, and you should have multiple ways of solving them. You know, those ways are to graph them and find the x-intercepts. Again, that's not the most accurate way. You can factor them, get it set equal to 0, set the factors equal to 0, and solve for the x-intercepts that way. Of course, not everything can be factored. You could get everything set equal to 0 and complete the square. Or you can do the quadratic formula. Again, everything needs to be set equal to 0 in all of these situations. And that is because we're looking for where the y value is 0. So now we're moving on, and we're on page 191 here. We're moving on and taking a look at how to solve and deal with quadratic inequalities. Now, we've done this before, but we're going to come back and look at them again. What is the vocab today, right, is what is a quadratic inequality? And so the quadratic inequality is just solving for a whole group of numbers. And it says here, you can graph quadratic inequalities in two variables by using the same techniques used to graph linear inequalities in two variables. Okay, so a quadratic inequality, and this is your definition of the day, is an inequality in the form of, right, y is greater than ax squared plus bx plus c, so we see the same setup as we were with the equations. Okay, and then they're running through the different options. Of course, it could be greater than or equal to, less than or equal to. But notice all of them are set up the exact same way, ax squared plus bx plus c. So to graph them, right, you just graph the function as if it was not, just inequality. Just treat it like we've been treating it. And, they suggest to test a point that's not on the parabola to see if you get a true statement. And of course, we'll go through all of this. And then shade in the right area. Now, we did this slightly different when we first saw it earlier. That was maybe even all the way back to first quarter. So let's see what they got going for us here. Okay, so graph a quadratic inequality as long as it's less than or equal to. And so then they give us this inequality and it says just graph it. Okay, so you guys have Desmos. You can use Desmos. You can use the graphing calculator. Okay, but we do know some things about this. So remember, we can find, we could change this to vertex form, but we can also start by finding the axis of symmetry with negative b over 2a. So that's what I'm going to do. So, if you remember right, we have a is 1, b is negative 2, and c is 8. So then negative b is the opposite of b. So in this case, it's going to be 2 over 2 times 1, which is 2 over 2, which is 1. So we know the we know that the axis of symmetry is at x equals 1. So I'm going to put that in right now. So then we can get our vertex, our y value of the vertex, by just plugging in the value we found for the axis of symmetry. So then I'm going to say y equals 1 squared minus 2 times 1 plus 8. So then that's 1 minus 2 plus 8. So negative 1 plus 8 is 7. So then our vertex is at 1, 7. Then I'm going to put that over here. And then other things that we can look at to get a nice graph here is that the point that it crosses the y-axis that's when x is 0. So these would become 0, plug in 0 here, plug in 0 here, those are gone. And so then the y value that it crosses the y-axis is at 8. And since this is a parabola, and we know that it is symmetrical, we also have a point here. So now we can get a nice graph going, and that, that's as accurate as we need. Remember, we are dealing with a less than or equal situation. And so then it's going to be a solid line that basically looks like that. So now we're going to pick a point to test. And you can pick any point as long as it's not on the actual parabola itself. So none of these points should be picked. You can pick any number here, you can pick any number here, but you should pick really easy numbers. And so, what you can see is that they pick the origin, 0, 0, which is clearly not on this parabola. The nice thing about picking 0, 0, and you should always pick it if you can, is that it's super easy to work with because we're just plugging in 0 every place we see. And so then we have this idea, is 0 less than or equal to 8? And yes, it is. So that means we're going to shade everything outside the parabola. Okay, and of course that goes on and on forever, but any point in that green area is a solution to this two-variable inequality. All right, so we're going to go ahead and move on to example 2 here. And the only thing that's changed from the first example to this example is that we're going y is greater than or y is greater than or equal to now. So, we're going to graph the equation again, and we're going to go through and get some of the same information. Always good to find the vertex. So I'm going to start with the axis of symmetry, negative b over 2a, right? In this case, a is negative 5, b is 10, and you notice there's no c, so c is going to be 0. So then negative b, right, that's always the opposite sign, so that's negative 10 over 2 times negative 5. So then we're at negative 10 over negative 10, and so that reduces to 1. So we know our axis of symmetry is at 1. We also know that the x value of the vertex is at 1. So to find the y value, I'm just going to plug that in. So again, I'm going to use it as an equation here. Y equals negative 5 times 1 squared plus 10 times 1. Please do your order of operation correctly. 1 squared is 1, so negative 5 times 1 is negative 5 plus 10. And so then the y value of our vertex is 5. So we know the vertex is at 1, 5. Again, you can use the graphing calculator or Desmos. So we're looking at about right there. Now, some other things that this function is telling us is that because a is negative, this is opening down. We see that, right, there is no c value. Our c value is 0. So again, that's where it crosses the y-axis. So it's all the way down here at 0, 0. And since this is symmetric over this line, this also must be a point here at 2, 0. Okay, make sure you check this. I didn't look closely right away. Right, it is a dotted line because it's not equal to. So let's see if I can do it. And then we're going to pick a point. So unfortunately, unlike the last example, we can no longer pick 0, 0, which we would want because our parabola is going through that. So we have to pick something that's not on the parabola. Okay, they picked 0, or I'm sorry, 1, 0. And so then they're plugging it in, right? The 0 for the y value, the 1 for the x value. Simplify it down. And we have 0. So is 0 greater than, well, what is all this? So this is negative 5 plus 10, so 5. So that means that point that we picked, 1, 0, which is here, that is not a solution, so that means all of this should be shaded. So I hope that green looks okay. Okay, so that's basically how you graph them. All right, so let's look how we can solve these things. Now this, there's a lot going on with this part of the book. And so they're saying all kinds of different things here. Okay, so they're first saying, okay, what happens when it's less than? It being all of this quadratic equation, well, inequality. What happens when it's less than 0? And then they say, okay, what happens when it's greater than 0? And then over here they talk about, well, if it's less than 0, if the whole quadratic function is less than 0, and then a is positive, we have this situation where we have an and statement and it's in between. And then they say, well, okay, so if it's less than, and then a happens to be negative, which would make it open down, then we're talking about things that are on the outside. And so then, then they flip it around on you. Okay, so what happens if the quadratic is greater than 0? And then they give you these two options again. Okay, and so I'm going to read through this and we're going to make this a little more simple. So, this is a choice for you. You guys can pay attention to this or you can do it the way I'm going to show you, which I think will be easier to deal with. But, right, what are they saying? So if the quadratic is less than 0, right, graph this. Set it equal, graph it, right? The important points that we're finding are the x-intercepts. Okay, so then if a is positive, it's still going to open up. So you find your x-intercepts, you know it's going to open up. And then it's saying which x values on the graph lie below the x-axis, because they're saying, like, look, it has to be less than 0. So below the x-axis is where our solution is. Okay, and then they say, okay, so even if you keep it this way and it opens down, right, because a is negative, you're still looking for the x values that are below the x-axis. And so then it pops out this direction. Okay, so I don't think that's super difficult. But then they flip it around on you. And they say, okay, fine. If we have our quadratic, and now it's greater than 0, so that's y values that are positive. So they say, well, if a is also positive, and this is where I think it gets a little weird, they have this graph. And they're saying, and again, I think this is kind of strange. But then they're saying, okay, so if this happens, so they're saying if your quadratic is greater than 0 and a is positive, we're still looking for, we still graph this quadratic and identify the x values for which the graph lies above the x-axis. Okay, and so that's why I think this is confusing, because it doesn't look right when we're looking at this. Okay, so, and then they go through and they kind of say, well, okay, well, a is negative. So here's what I'm going to say. Here's what I think is much easier to think about. I always want my a to be positive. I don't want to mess with learning too many things. So here's some things to keep in mind. Or here's some ways to think about this. And I don't see a good example here, but let's say, so we want, I'm looking at the future examples, but okay, so look, so we want, step number 1, so firstly, get all terms on one side. Okay, and you're not going to have to mess with this too much because usually they give it to you in function form. So then change y to 0. And then what I would do is I would force a to be positive. So I'm going to add some things here. Right? If a is negative, multiply every term by -1. Remember, that means you have to flip the inequality sign. Okay, so we're just going to force a to be positive. So don't worry about doing anything if after you set it equal to 0, a is already positive. You don't have to do this step. It's only if a ends up being negative. So then all we have to do is pay attention to this sign. This sign. Okay, so step number 2, if you have it like this, and it's less than or equal to 0, you have an and statement. Okay, if, however, you have it greater than and equal to 0, you have an or statement. Okay, and I'm going to tell you a little bit more about that here in a second. Okay, so if we come back over to what they're saying, this would be an and situation. So, and then this would be your or situation. Ignore the graphs because we have made a positive no matter what. So, if you have an and statement, and it all has to do with what the direction that your inequality is, the solutions are in between the x-intercepts. If we have an or statement, again, that's this setup. If we have an or statement, then the solutions are outside the x-intercepts. Okay, so let's take a look at some examples of that. Okay, so what do we need to do this? So we already have it set up. It's all set up to 0. This is less than, and we already have a positive a. So we're not going to mess with multiplying by -1. We're happy. It's going to be positive. This is telling us it's going to be an and statement. This is from the previous page. I'm not going to flip back and look at it. You should have it. So we know that after we graph this, that the solutions are going to be in between because of the way this is pointing. So remember, the important parts here are your x-intercepts, not the vertex anymore. That was the previous 2 examples where we actually had to graph everything. The important points now are these. Now, how do you find these? Well, that's what we just spent the last couple weeks doing, finding our x-intercepts. You can use a quadratic formula every time, right? A is 1, B is 1, C is -6. You can plug it in, simplify, and then you can know what these are, okay? This happens to factor, and factoring is way quicker if you recognize it, because we're thinking of, right, 1 times -6, factors of -6 that add to give you +1. That would be +3 and -2. We set those factors equal to 0. So we say, okay, so x minus 2 equals 0. Add 2 to both sides. So x equals 2. Set x plus 3 equal to 0. Subtract 3 from both sides. So x equals -3. Okay? So, we're using a lot of stuff that we've been working on, so you got to keep it all straight. So then what we're saying is, since we're less than, that means it's and we're going to have all these solutions in between. So the graph lies below the x-axis. This is what they're telling you to think about, okay? I'm saying just look at the direction. I'm just saying look at this, making sure that A is positive, and then you know that it's in between. So it's between -3 and 2. So then the solution set is, I'm going to read this so you guys remember, x such that x is greater than -3 and less than 2, and, okay? And then they want you to do it in interval notation, okay? And it's been a while since we did that. So this would be interval notation. It looks like it's a coordinate, but what this is saying is from this point to this point. And these rounded brackets refer to the fact that it's not equal to. All right, so let's look at the final example here. Okay, they have it set up for us nice and pretty. They have the direction this way now. Okay, and notice that A is positive, so that's good. So we can skip that first step from the previous page. We're just going to start and graphing this. Again, the important parts are where it crosses the x-axis. You can use A is 1, B is -3, C is -4, plug it into the quadratic formula. But again, they gave us another one that factors. So 1 times -4 is -4. Factors of -4 that add to give you -3 are -4 and +1. So then, this is where you're setting this equal to 0. Add 4. So one of our solutions, one of our x-intercepts is at 4. Set the other one equal to 0. Subtract 1. The other one is at -1. Okay, so again, I'm not really paying attention to what they're saying exactly. I'm thinking of the way I wrote it. And so then it says, since we know, again, the way I think about it is, since it's this direction, it's going to be an or. And I got A being positive. Okay, so then that means it's on the outside. You see how they graphed it on the outside now, because it's an or statement. Okay, so then the graph, so when x is less than or equal to -1, those are solutions, or when x is greater than 4. Okay, so then they have the or statement here. Either of those are true. The notation, the set notation here, or the interval notation, interval notation is a little bit differently. Okay, so then we're coming from the left. So then we're coming from -infinity, and then we're stopping at -1. You can never get to infinity, so it's always a rounded bracket. -1 is included because our original function was greater than and equal to. This means that's called a union. I don't know how much we've talked about that, but that union says solutions could be here and they also could be over here. Or they could be over here is a better way to say it. Okay, and so then now we're saying include 4, that's what the square bracket means, and go all the way to positive infinity. All right. So you can take a look at the check if you want, but this should get you in a good place to do 1 to 19. And that would be on page 195. Make sure you guys ask when we see each other next. If you get to this today, send me an email and ask a question.